physics. You should be finishing your acceleration notes that we started in class. So fast forward this to wherever we left off in class. Might be in the math examples, just the practice math, or it might be the actual examples 1 through 6. Pause the video and try calculating things yourself. Don't just sit there and write. Make sure that you can actually calculate and solve these yourself. Now, just because we're looking for acceleration doesn't mean we're going to use the A equation. What you're doing is looking for the equation that has these 4 variables in it. So you can tell we can't use the acceleration equation, the A equation, because we don't have VF on our list. The final velocity is not on our list. So you're looking for something that has these 4 and only these 4. You can tell we need the D equation. So always write the equation first, and then in the second row, plug in the numbers. Then you're ready to solve. Just remember your order of operations. Please excuse my dear Aunt Sally. You need to do your exponents first. I mean, there's parentheses, but there's nothing in there to do. So you're doing your exponents first. It's only the 8.9 that gets squared. So you can do the 8.9 times 0.5. The 70 times 0.89. Now to get the A by itself, first I have to get rid of this term. These are added together, so I need to do the opposite of adding to get them apart. I need to subtract 623 from both sides. To get A by itself, I need to get rid of this. You can tell they're multiplied together, so I need to do the opposite of multiplying to get them apart. I need to divide both sides by 39.6. And my answer is negative 7.53. Okay, you can see I wrote it wrong here in the video. It should be 7.53. These two are switched. You need to add that the acceleration is 1.25. I just didn't fill that in so you couldn't work ahead on the worksheet if we were doing these in class, so that you would stay with the class and help your neighbor. So I'm looking for the equation that has these 4 things in it. It can't be the acceleration equation because I don't have a T. Just because I'm looking for D doesn't mean I'm using the D equation. I'm not, because I don't have a T in my list. The equation that has these 4 variables is the V final squared equation. I write my equation. I line it up and plug in the numbers. Please excuse my dear Aunt Sally. First I'm going to do my squaring. 12.7 squared and 5.85 squared. Here I did my multiplying, 2 times 1.25. I'm going to subtract 34.2 from both sides. To get the D by itself, I'm going to divide both sides by 2.5. Remember, technically this D is displacement, not distance. The displacement is 50.8 meters. So the final velocity is 51.5. Write that on your paper. Look at the 4 variables you have and pick the equation that has those 4. I hope you picked the A equation. Write the equation, plug in all the numbers. I'm going to start by cross multiplying. And really, when I cross multiply, what I'm doing is multiplying both sides by t. And now to get t by itself, I'm going to divide both sides by negative 3.33. And you got t equals 13. If I want to keep three sig figs, I'm going to do 13.0. Got to fill in the 30. The d is 30. And then pick the equation that has those four variables. Notice there's no A on my list. Acceleration's not on my list. I don't know what it is, and I don't want to know what it is. But I do know that my velocity is changing, because here's what it starts at, and I'm to find what it ends at. So I know it must be changing. It's not a constant speed. But remember, you can use the average speed equation, v equals d over t, where v is the average velocity. And to get the average of two things, you add them up and divide them by 2. So I'm adding the v initial and the v final, dividing by 2 to get an average. So that v equals d over t. I'm going to plug in my numbers. There's different ways you can go here. I'm going to simplify kind of two things at once here. I'm going to multiply both sides by 2. So the 2 cancels here. So over here I have 30 times 2 divided by 25. To get the final velocity by itself, I need to get rid of this. They're added together, so I need to subtract to get them apart. So I'm going to subtract 4.35 from both sides. And I get that v final is negative 1.95. Okay, ready to solve a physics problem now. So you need to just pull the information out yourself. You're always going to have 4 things on your list. It's always going to be 3 things you're given and 1 thing that you want to find. So I put that on my list too with a question mark. So I'm just reading straight through the problem. What is the acceleration? So I'm looking for acceleration. That's my question mark. Of an object that goes from negative 45 meters per second to negative 12 meters per second. So that's velocity, it's meters per second. So this is when it starts, this is when it ends. So I've got a v initial and a v final. And in 6 seconds, so of course that's time. Before we even start this, let's think about it. What direction is it going? Negative. The whole time it's negative. Negative 45, negative 12. So it's going in the negative direction. And if it was going negative 45, then negative 12, I know it's getting slower and slower. So that's a minus, minus. I would expect my answer to be a positive acceleration. Let's hope this works out. The equation has those 4 variables in, is the acceleration equation. I can plug in my numbers. The a is already by itself. So that was negative 12 minus a negative is like adding. So negative 12 plus 45 divided by 6 then. 5.50. So yeah, it is positive, just like I expected. Example 2. Again, I have a blank here just so you can work ahead. So fill in the blank. An object has an acceleration of 3.85 meters per second squared. So there's my acceleration. Acceleration is 3.85. If the velocity is 13.5 now, what will it be after 6 seconds? What will the velocity be later, at the end of the problem? So when the problem starts, it's 13.5, and I want to know what the velocity is at the end of the problem. That's my question mark. And the end of the problem ends after 6 seconds. So my time is 6. Look for the equation that has these 4 variables only. It's going to be the A equation. Plug in your numbers, lining everything up. I'm going to start by cross multiplying, where I multiply both sides of the equation by 6. And now to get the VF by itself, I need to add 13.5 to both sides. And I get that the final velocity is 36.6 meters per second. Example 3. How far will the object from example 2 go, again, little typo, that should be G, go during those 6 seconds? So even though I just found V final, I don't want to use that because I already rounded it out a little bit. You want to go back to the original information. So if you look back in example 2, what I was originally given was the acceleration, V initial, and time. The difference is this time I'm looking for the distance. How far? So pick the equation that has those 4 variables. It's the D equation. It's not because it's the D equation, it's because that is the equation that has these 4 variables. I'm going to plug in my numbers. I'm going to simplify this, 13.5 times 6. And over here, remember, it's just the time, just the 6 that gets squared. So it's 6 squared times 3.85 times 0.5. And I just add those together, and I get 150. I put a line over so I have 3 sig figs. Make that placeholder significant. Example 4. Again, you have to fill in that blank. It's 45.0 meters. So if I make my chart, what is the acceleration of an object that goes from 12.6 to 34 meters per second? So it starts at this velocity and it ends at that velocity. So I have a V initial and a V final. And remember, the distance you're given is 45 meters. So look for the equation that has those 4. We're looking for acceleration, but you can't use the A equation because we don't have a T in our list. I hope you picked a VF squared equation. Plug in the numbers. Before we go any further here, let's think about this again. What direction is it going? Positive. Positive 12, positive 34. Is it going in the positive direction? Is it getting faster or slower? 12.6 up to 34, it's getting faster. So plus and a plus, we would expect to get a positive number for our answer. Let's see. I'm going to do my exponents first. So I'm squaring the 34. I'm squaring the 12.6. I can multiply the 2 times the 45. So 2 times 45 times A is 90A. I'm going to subtract 159 from both sides. And now to get the A by itself, I'm going to divide both sides by 90. 11.1 meters per second squared. That's the unit to measure acceleration. Example 5. An object decreases its speed from 52 to 20. So it was going this speed when it started, and then it slows down to that speed. So I've got a v initial and a v final. And it does that while it's traveling 35 meters. So that'll be the displacement. How long does it take? So when I ask how long, I'm not asking for a length. I'm asking for a time. Look for the equation that has only those 4 variables. So this is weird because I know it's accelerating. I know it's accelerating because it changed its velocity. But I'm not given what A is, and I'm not asked what A is. So even though this is accelerating, I'm not going to use one of those acceleration equations. I can figure out the average speed and use my average speed equation. So to average my speed, average two things, I add them up, divide by 2, and v equals d over t. So remember, it's kind of that fourth equation. Plug in my numbers. A couple ways you can do this. It's easy enough to simplify this side without cross multiplying or anything. So 52 plus 20 divided by 2 is 36. I'm going to get to t by itself, but it's on the bottom here. So I'm going to multiply both sides by t, so I don't have a t down there in the denominator. So now I have 36t equals 35. If I'm going to get t by itself, I'm going to divide both sides by 36. So t is 35 divided by 36. I get a calculator, and 35 divided by 36 is 0.972. And that's a time, so it's seconds. So all of these examples so far is what I call just a one-step problem. I made one list of 4 things, I picked the one equation that had those 4 things, and I solved it. These are one-step equations. Example 6 is a little different. An object starts rolling from rest. How far does it go in the 5th second if the acceleration is 6.75? So as something rolls down a ramp, the acceleration stays the same, not the velocity. It gets faster and faster as it rolls down the ramp, but the acceleration is the same. It gets faster and faster at a steady rate. This one's getting 6.75 meters per second faster every second. And I'm not asking how far it goes in 5 seconds. I want to know how far it goes in the 5th second. So I think it helps on this to make a sketch. Okay, so the ball starts here at the top. After 1 second, maybe it rolled that far. But it's getting faster and faster. So after another second, maybe it's down here. And maybe another second, it's down here. See how it keeps going farther and farther in every second because it's getting faster and faster. So this is the first second, there to there. This is the second second, the third second, the fourth second, and the 5th second. So I'm doing a problem for this 5th second. So the problem that I'm solving starts there and ends there. That is the 5th second. So I want to make sure when I'm putting stuff on my list, it only applies to the problem I'm doing, which is from here to here. Well, does it start from rest? No, not for this problem. It's sort of rolling from rest. Up here, the velocity was 0. But that's not even part of my problem. I'm doing this problem. So what I know for this problem is I'm looking for the distance. I know the acceleration the whole time on the ramp is 6.75. And I know the time is 1 second. Remember, there to there represents the 5th second, just 1 second, the 5th one. And then I need something else on my list. I can't solve it with just, I can't solve it with just 3 things. Any ideas? We already said this V initial is not 0. Do we know V final then? Do you know how fast it's rolling here? No. So the only way to solve this is if I can figure out either V initial or V final. And there's different ways to go about it. There's a couple, there's a couple ways that you can do this. Would you agree that if I did this problem, the problem that starts up here and ends down here, the V final for this red problem is the V initial for this purple problem. Where that problem ends, this problem starts. So the velocity right here is representing V final for that problem, but V initial for this problem. So if I solve that problem and get V final, then I can put V initial in here and solve this problem and get my answer. So let's make a list for that red problem. V initial is 0 because it did start from rest up here. So this problem does start with a velocity of 0. I'm looking for V final. Same ramp. Acceleration the whole time is 6.75. And the time for that problem, 1, 2, 3, 4 seconds. I just pick an equation. I'm looking for V final, but the VF squared equation is not going to work because I don't have D in my list. I'm looking for the equation that has these 4 and only these 4. It's going to be the first one, the acceleration equation. I write my equation. I line up my numbers. I'm going to multiply both sides by 4. Would you agree that if I did this problem, the problem that starts up here and ends down here, the V final for this red problem is the V initial for this purple problem. Where that problem ends, this problem starts. So the velocity right here is representing V. So 4 times 6.75 is 27. I should have added 0 to both sides, but I'd feel silly adding 0. So remember, I'm not done. That's not my answer. That's where that problem ends. So that's V initial for this problem. So V initial for this problem is 27. So now I pick an equation and solve for the distance. V final for that was V initial for this. Looks like I'm going to use the D equation. Not because I'm looking for D, but because that's the equation that has these 4 things in it. Just a little simplifying. 27 times 1. 1/2 or 0.5 times 6.75 times 1. 3.38. I just add. It goes 30.4 meters in that 5th second.